February 29th. Jeez, oh, Pete's March is next week. I can't handle that. Yow! That's craziness. Do you guys not agree with that? Where did this year go? You're like, it's been forever, lady. We've been with you since August. You're not responding to me at all. Do you see what I mean?
Wow, crazy.
I know, exactly. What's that? How late? I don't know. If people still have questions. It's okay. All right. Yes, because she loves calculus, just like all of you do. Do you all see we have a visitor today?
Dedication.
Yes, indeed. Now, I had some questions earlier today, and the questions earlier today had nothing to do with this stuff down here. Actually, they did, but it won't pertain to you. The questions were, and I'm not really sure what Big Scala has to do with, but this was just the information I gave you yesterday. I went ahead and put it on the board because they wanted to know again, when is the date? What do we need to do, obviously. Now, I love this. When I filled out the little, whatever, the website thing, it said, make sure students are at door 12. I was like, door 12? What the heck is door 12? Door 12 is otherwise known as the door you come in through the student parking lot every day of your lives. But you probably never look up and see door 12. I just thought I'd share that with you. You know, I don't know any of the doors. Wouldn't you think? Because that technically, when the architects built our school, that's door 1. Like, that's the front of our school, which is bizarre and strange. But anyways, that's the student lot. Now, I didn't put this up for my first block class because they laughed and giggled at me like, duh, moron, we're going to be in your first block. I put that up for you guys because you have a different class first block. Please do go to your first block class. You'll be there for about 25 minutes. Before you guys, I don't even know that an announcement will be made. So just 7:50, head toward door 12. In code, door 12. So it's the student, that way I can take attendance, make sure everybody's there before we get on the buses and go. Remember that unless you pay, you can't go. Otherwise, and I have to make sure that I have like all the money for everybody. Otherwise,
Do you need it beforehand?
yeah, I do, because I need to pay the woman. Wow, that's impressive.
I came in late to this.
Wow, that's good. That's 2 people today. I'm really impressed. Even after I just put that up there yesterday, that is sweet. What was I going to say? Shoot. I need to pay the lady that, or the gentleman, whatever the case is, that day. Okay, so today, you guys should have, seriously? Look how this class,
Oh, I got my.
that ratio is so much higher than block 1. They only had 1 person, but their class is bigger. Yahoo! I'm impressed. Always impressed with you guys. So, I'm happy to answer questions for you. And or, if you're still working on your practice test, I hope that you started, okay, hold on one sec. You said number 2, okay, hold on one second. And I will, let's see if I have a blank copy of said test. I know I do. Yep, and you guys are in, I just need to get the right blanker out. Okay. Alrighty. There we go. Extra practice. This is the one I need. Okay, you said number 2. Wait, is this one you asked me about yesterday? Okay, but then they weren't in your class, so this makes, you're probably fine with this. Okay, number 2's answer should be A, right?
Yes.
Okay, let me explain why. Actually, we have a guest star in here. I can explain number 2 to you, but I won't put her on the spot. Now, if you guys look at the directions, remember, a big part of your job is being a math detective. In other words, understanding kind of what they're asking about. So when they start with f is a linear function, if f is a linear function, what's that mean? Interpret that for me, explain. That means it's a line. Okay, so let's just use an example here. Let's just pretend for a minute that f of x is 3x plus 2. Would you guys agree that's a line, that's a function? Okay, so let's do this. I believe that the problem asks you guys to do f double prime of x, and then, strangely enough, it says from a to b, and you're like, how the heck do I do that? I don't even know what they are. But let's do this for a minute. I'm going to need to figure out what the second derivative is in order to be able to set up the right integral. Okay, and I realize I know I just made up an example, but I think you'll be okay with this in just a second. If this is a line, and you guys do your first derivative, what is the first derivative of 3x plus 2? 3. Do you agree with that? Think back to your derivative rules. You decrease your exponent by 1. So it would mean keep the 3 where it is, and then times 1x to the 0. Then take the second derivative, we'll take the derivative of that, or the second derivative of the original function. What's the derivative of 3, guys? 0. Melissa had the preview of this yesterday, because this was her very same question. So here's the deal. You guys are trying to integrate the function 0 from a to b. Well, graphically, if you sketch the line, the function 0, y equals 0 is the x-axis, and it does not make a hill of beans difference where a and b are, because if you're just integrating, listen to me carefully, under the x-axis to the x-axis, how tall is that area? Exactly. So graphically speaking, you know your answer is 0 now. If we tried to do this with the calculus rule for antiderivatives, you of course could put times x to the 0, and then you'd have, oh, well wait, I get x to the first with a 1 over 1 in front, but I have 0 in the back, right? Or excuse me, in the front. I have this coefficient of 0, so my answer is still going to be 0, even if I plug in b and a. Do you see why now it's 0? The reason being, they said f was a linear function. I could have done this like I did on the answer key, or like you guys took a look at it. I might have said, hey, let's just consider it mx plus b. Once again, your derivative, it doesn't matter what I originally started with. Wouldn't the derivative of that just be m? And the second derivative then, m is just a plain number, it would be 0. So I just wanted to use an exact answer for you, like a real function like I did with her class yesterday. To give you an idea, that one's not that hard. It looked like, how in the heck am I supposed to do this? Because I don't even know what my function is, but you have to tell me that one wasn't that bad. Come on, see the light. You're on the other side of the rainbow now. You're like, all right, that was an easy ride there. See? And you were like, oh no, I can't do this. Enough with the, oh no, I can't do this. That's just not the case. Not the case. Good guidance water, they do have them. Yes. It's not, especially not like water fountain water. Dude, I've yet to find a water fountain in this building where I can take a sip of it and go, ah, refreshing. Instead, it's like, ooh, that's gross. Okay, yes, ma'am. Sure. Same stuff, starting with number 6. Okay, so 6 I may have to start with some given. You tell me that f of x is made from the sum of 2 other functions. So, oops, excuse me, it's supposed to be h of x first. But I doubt that that matters. It's h of x plus g of x. And that happens when x is in between, oops, it says x less than or equal to 10. Okay, so it's kind of like, you know, I could just say, here's an example. Wouldn't you guys agree that f of x here would be the sum of 2 functions? Do you see what I'm saying? I mean, that doesn't mean anything wild and scary. But anyways, okay, so here's what they want us to do. They want us to do the area from 0 to 10 of f of x minus 2h of x plus 3, and all that's in a parenthesis because that's the function that they've created. Now, oops, excuse me, times h of x. What they want you to remember, guys, is that you can split up areas. We can split them up like graphically on the first page. You probably did that to find the answer to number 3. But if I'm doing a problem like this and I don't know what the functions are, what they want you to realize is that you guys can go from 0 to 10 and find the area underneath f of x. We'll get to that in a second. Well, we can do this a bunch of different ways. And then minus the area of 2h of x. This is one way to do it. I should have dx's in this each way here. Plus the area of 3 dx. This is from 0 to 10. Oops, yeah, and 0 to 10. That's one option. Or the other option would be this. See how they gave me a rule for f of x, guys? They said, hey, plug this in for it. So another way to do this would be to just say, let's take this out, what f of x stands for, and put in h of x plus g of x. So let me do this. So it's just a different way to look at it. Is one right, one wrong? No, they're both right. It just depends on which way you guys would rather do this. So I could just do substituting up front, and then minus 2h of x, and then plus 3. And And then I'm just gonna ask you to simplify. Do you guys see anything that simplifies here? Do you notice anything that like algebra 1 kind of simplifies, like cancels or anything? Okay, so you have an h of x and a negative h of x. So you have a negative h of x plus a g of x plus a 3. And then you would do that from 0 to 10. Okay, so we're still gonna need to do a little bit of creative mathematics. Now, if I did it this way, I'm still gonna have to do some substituting because I was told f of x is h of x plus g of x. And so this is from 0 to 10. Which, before I go any further, guys, which way would you prefer me to continue? The way on number 8. The way on the right, is that what you meant? Okay, okay. So you want me to just scrap that and just do this part over here? Okay, so now we're gonna split these up and do these in 3 pieces. Okay, we need to do these in 3 pieces. Now, do you see the little negative sign here? This is like a coefficient, just like if we were doing derivatives. We can pull the negative one out in front. So we need to know the area underneath h of x. Hopefully it was given, but maybe not. Number 6. Oh, we don't even need to do that. Okay, we just need to simplify this thing. So there's negative 1 plus the area of g of x. And this is from 0 to 10 dx plus 0 to 10. That's 10. And then dx. Now, I don't think, excuse me, if this is anywhere on your sheet, or I guess I could have just flip-flopped the order here. I want you to answer me this one, because this is the only one of the 3 of these that I'm able to do, because it's actually a function. Y equals just 3. So we could either do this graphically. You guys are looking at the function y equals 3, and you're trying to find the area from 0 to 10. How big is that, ladies and gentlemen? 30? So this is 30, or you could actually do it with the calculus. I could do it with the fundamental theorem of calculus. Now, as far as these 2 things go, I don't see an answer on here, but I do see several of these plus 30. Now, I can't do this because they didn't give it to me. Follow me there? Beats the heck out of me how to do this. Beats the heck out of me how to do this. So what I could do is combine these 2 and just write this. I see one of the functions on here, one of the answers on here, as g of x minus h of x, and then dx plus 30. So that's, all I'm doing is putting that back to 1, because I don't know how to do that. They didn't give that to me. If they gave it to me, I would choose those and plug those in. But here's what I end up with. Oh wait, no, I'm okay with not a 2. So I get a g of x minus h of x plus a 30, so it would be d. Yes?
Why don't we multiply 3?
Why do you multiply 3 and 10? Okay, well how do you, first of all, there's 2 different ways to do this. The other way to do this would be to do this in calculus form. If you guys were doing the calculus that you just learned, and it said do this, you would look at that and go, well that's 3x to the 0. Like if I'm using the stuff that I just taught you this past week, or the last week. So you go, okay, how do I do the antiderivative of x? I get that, right? And then I have a 0 down here and a 10 here, and I keep the 3 along to the right. So this means that I'm plugging into 3x, and I'm supposed to do x equals 10, and then I'm plugging into 3x, and I'm supposed to plug in x equals 0. So this is 3 times 10 or 30, minus this is 3 times 0, or just big fat 0, so I get 30. The reason I was doing it this way is I was saying graphically, if you think about this graphically, this means that you're graphing the function y equals 3, forever and ever and ever and ever and ever. But this means you're finding the area between 0 and 10. So our rectangle here has a height of 3 and a width of 10. So you could have done it graphically and gone, oh, my area for that last part is 30. Or you could have just done it with calculus and said, oh, if I do that calculus method, my area to that is 30. How's that? Good questions. Let me take a look at this and see if I have any of the problems on here. Oh, good, I do. I have Remind some problems on here. That's good. 9, you said? Okay. 9 on the first part? Yeah, 9's on the first part, is what you're saying. Probably page 2-ish. Okay. All right. So, number 9. I guess I could erase this or just jump here. So, the area of the shaded region in the figure on the right is equal to exactly the natural log of 3. Interesting. So, here's 9. So we've got this picture, looks like this. This is 1, it says this is equal to the natural log of 3.
You're right.
If we approximate the natural log of 3 using left hand and right hand partitions, right hand Riemann sums of two equal partitions, which inequality follows. Okay, well my first question is this. We integrated underneath some function, dx, we got our answer as the natural log of 3. And so would you agree that I went from 1 to 3 and found the area of some function and got natural log of 3? So I need you guys to think about this, just calculus-wise. What is it if you do the antiderivative of, let's see. That's gonna help. No, I was trying to think, I'm thinking out along the lines of explaining this differently. I don't know if that's gonna help. Because when you're doing antiderivative, oh yes, it is.
1 over.
That's what I'm getting at. Do you guys remember this? That a long time ago, you learned that if you guys take the derivative of natural log, you get 1 over x. What that means then is if I try to do the antiderivative of 1 over x, I would get the natural log, like going in this direction. So what I'm trying to get at is, if I get the natural log, then what did your original function have to be? It had to be 1 over x. So what I want you to see is this picture right here is the function y equals 1 over x. It's not the natural log. The natural log of 3 is just the shaded area, okay? So what I need you to see is, remember, this had to be a 1 and this had to be a 3. Now, when I get to this means I'm supposed to plug in a 1 and a 3. And so watch this. I get natural log of 3 minus natural log of 1. What is natural log of 1? Isn't it just 0? That's, natural log of 1 is just 0. That's why natural log of 1 literally crosses through right here. It's not that that's the natural log graph. But anyways, so here's what they're asking. They're asking you to do a left and right Riemann sum with the function 1 over x. Because we've now figured out that that graph of the function that you guys are taking a look at is 1 over x. And what we were doing is estimating the area. Well, we were actually starting with the actual area from 1 to 3. They say estimate it with a left hand and a right hand Riemann sum. You guys tell me which one's going to be a bigger area. Left-hand sum or the right-hand sum? Watch what happens when we do the left-hand sum. The left-hand sum is going to look like this. Is that going to be an overestimate or an underestimate? That's going to be an overestimate. So let's just do the left-hand sum first. Now, each of the rectangles that I have here, guys, are how wide? They're 1 unit wide. And then the y values would be found, like if we're doing the left-hand side, by plugging 1 into this. So this y value would be 1. So if we're doing the left-hand side, it would be 1 times 1. That's the rectangle on the first part. I know my picture's off a bit. I realize 1 is not this skinny and this tall, but you with me there. And then this one over here, your left-hand endpoint would be a half. So it would be 1 times 1 half. It's looking to me like we get 1 plus a half or 1 and a half. Let's just do both of them and decide which one's small and big. Now, if we want to do the right-hand endpoint, I'll do this with dotted lines. The first one would look like this, and the second one like this. So that would be this part here and this part here. You guys follow me there? So if I did the right hand endpoint, this first rectangle is a width of 1. What's its height? It's this point, 1/2. Nice job. Good answer. And then what's this height? 1/3. Nice answer. So if we add 1/2 and 1/3, that's 3 over 6 and 2 over 6. We get 5 over 6. Which is bigger, 5 over 6 or 1 1/2? Okay, 5 over 6 is clearly smaller, right? And 1 1/2 is clearly bigger. So what they wanted us to do is just track the area between, so the actual area under the curve, not from 0, my apologies, from 1 to 3, as we figured that out, of the function 1 over x dx, is in between these two, that's a less than, and in between those two. Does that make sense then? Does that help you?
Yes.
You're making a face at me now. So that means the area on the left is 5 over 6, and the area on the right is 3/2, so 1 1/2. On your papers, guys, this says 3/2, but isn't that the same as 1 1/2? So it would be E.
Yes.
Did I put the answers on the last page like upside down or something?
Yeah.
Like, but the work isn't there, but at least you have the answers to, no, I guess I didn't.
Well, we use that.
Oh, you used that. I swear I thought I had it. Okay, guess not, but hopefully you took pictures of it. That's what I was looking for. What's that?
They are on the
They're on the
last
last page?
page. They're written upside down on the bottom.
Oh, well, maybe mine isn't the one that I Xeroxed for you. Okay, then that's good. Good. Okay, then I must have copied a better one from you. Yes.
Number 7.
Yeah, same page?
Yes.
Okay.
I don't know that.
All right, so this one looks like, just glancing, that we're gonna have to do a little more calculus stuff rather than just big picture stuff. Ouch. Okay, so number 7, what are all the values for k? So number 7, k equals what? And we're supposed to find all the values for which negative 3 to k of the function x squared dx is equal to 0. Okay, let's pretend that we don't know any of the answers, and let's just pretend like we're gonna do this. Like our numbers, our limits of integration were given to us, and we're ready to go to town. Like, I'm just gonna go ahead and do the antiderivative of this. So the antiderivative of this is, you guys tell me, how do you take the antiderivative of x squared? Do the calculus for me. You get x to the third with a 1/3 in front. How am I doing with the calculus? I'm using the purple on purpose. Okay, and then this just happens to have negative 3 down here and k at the top. Ignore the equals 0, ignore that I don't know what k is, just pretend like we know them, and show me what to do next. What do we do next? We take our quantity right here, and we plug in these two numbers. So we're going to have 1/3 times k cubed. Because we're going to plug in the top limit of integration first, and then we're going to have 1/3 times negative 3 cubed. How am I doing so far? Pretending, of course, that I can get an answer here. I know that it's set equal to 0. I'll get to that in a minute, but let's simplify. There's nothing I need to do here. We could just call this 1/3 k cubed. Now let's talk about this. If you take this negative 3 and cube it, what's 3 cubed? 27. And so if you were to take 1/3 times negative 27, what would you guys get? Okay, so you'd have negative 9 in the back of this set of parentheses, and you're supposed to be subtracting negative 9. What do you get then? Plus 9. Okay, so I'm supposed to get plus 9 here, and then this is supposed to equal 0. Why is it equal to 0? Because the problem said let it equal 0 and solve for k. So you see right now, all I'm doing is plugging in the top limit and the bottom limit, and then going, oh, by the way, they want me to set equal to 0 and do some algebra stuff. Just solve for k. And come up with, they said come up with all values of k that make this work. So how do you think we're going to try to solve for k here? What should we do first? Or subtract 9. So 1/3 k to the third equals negative 9. How am I doing so far? So from here on down, ladies and gentlemen, algebra. The only calculus in this problem was the purple. That's what I wanted to stress. That's why I used the purple for the calculus. Okay, what are you going to do to get rid of the 3, ladies and gentlemen? Multiply both sides by 3. So you get k to the third equals negative 27. Is that a number that you recognize that is a perfect cube? I'll give you a hint. 1 cubed is 1. 2 cubed is 2. Guess what 3 cubed is? Now 3 cubed is 27. So what number was cubed to give you negative 27? Negative 3, yes, you are indeed doing a cube root. Now, here's a little walk down memory lane. Do we need plus or minus when we do a cube root or an odd root? No, we don't, because there's only one number that works. So all they wanted us to do was a little bit of algebra at the end, and there's a very small amount of calculus in the middle. You just want to go, don't worry about this thing that you don't know k at the beginning. Just pretend you know it, and do it like you know the problem. Just plug in k instead of a number. And when you get to here, you're going to set it equal to 0 and just do some algebra and solve it. So not as bad as you thought.
I'm just confused because when you like x squared is a parabola,
Yeah.
and shouldn't the area be 0?
Okay, but here's the thing.
Because it just touches the origin.
This does mean x squared is the parabola, but this thing said go from negative 3 to whatever the x value is, right? Okay, so, ooh, that's a good point. I don't think we're finished there. Okay, so if we graph a parabola here, do you guys agree that negative 3 would give you an area of 0? Because negative 3 to negative 3, if you integrate from negative 3 to negative 3, shouldn't that give you 0?
Oh,
It's
I
not a
get it.
space,
Oh.
right? But if you guys thought the answer was 3, remember that this answer, that area, would have been added with that, and it would be positive, you wouldn't get 0. So 3 isn't gonna be an answer, if that's what you were kind of thinking.
Yeah, I understand.
Do you see what I'm saying? If we had a problem to start with, it was x to the third, and you were given one of these, and you were like, when is it 0? And -3 was one of them, and the other would be 3.
Yeah, I didn't
Yes.
think that we were like.
Yeah, we're finding the area underneath this, not this. I know exactly what you're saying. That's, what's that? You probably wouldn't have.
This is just -3 and -3.
Yeah, exactly. Well, it depends on the function. If the function had graphs on both sides of the x-axis, you'd have to do the calculus.
Yeah.
Well, actually, if it's symmetric, you probably wouldn't. But if the graph, like in this case, you probably didn't have to do the calculus. You could have gone, the only way for this area to be 0 is if we start and stop at the same thing. This is what Alyssa's saying, guys. The only way for your area to be, I don't care what the function is. Wouldn't this always be true? You would end up with 0 if you start and stop at the same number. Do you see what, I mean, like, sometimes there's the long way, which I just did for you, and other times there's the like, I should have had the 8 way. Like, I should have seen that ahead of time, like, dumb, I'm hitting myself in the forehead, like, I didn't even really need to think about that one. Although, if they give us this, and they said x to the third, and they said -3 to k, and they said find all the answers, here's the part, this is kind of what Josh was talking about, guys, and I think it's worth considering. If they said find the area that makes this equal to 0, do you all see how -3 would have worked, because that would have meant you're finding an area of a line segment. But do you all see how 3 would have also worked, because these two areas would have been exactly the same except for one's positive, one's negative. Do you see what I'm saying? So don't just look at, like, it could have potentially, depending on the function, it could have had 2 answers. It just didn't happen to in this case because it was a parabola, you were finding the area underneath. So that was an excellent question. That means you really understand what you're doing. Really good. Really good. Yes, ma'am? Yes, Jelly, absolutely. You do know that he calls you Jelly, even when he sends me a text and says, yeah, Jelly goes. Okay, so number 10.
I actually sausage goes nicer than that way.
Graph of the derivative is shown on the right-hand side. Okay, so probably your graph is better than mine, of course. But the idea for this is 1, 2, 3, 4, and then the next point looks like it goes through is 2, 3. 1, 2, 3. And then it goes over here to 3, 3. And then through 4. And then down to like 6, -2. Okay, so here's what our graph does. It looks like it does this, and then this. Okay. And it says, which of the following is true? What? How in the world? Okay, how are they getting like f of 0, f of 6, f of 2, f of 4? So what you want to understand, remember, you've learned from my lesson, do not skip reading what they tell you above the problem or the instructions, whichever way the case it is, right? Okay, they have said this is the derivative. Are you with me there? Okay, so if this is the derivative, we do not know what the original sketch looks like. That's what I want you to understand. I have no idea what the derivative looks like. Are you following me there?
Yes.
So I'm going to draw the, like, pretend here a little bit. Using my sketch for the derivative, I'm going to go, okay, looking at my graph here, I know that one of the places where this okay, this is a point where your derivative is 0, so I know over here at 4, the derivative is 0. I know the derivative was positive between these two spots, between, let's see, 1, 2, 3, 4, 5, 6, 7, and then over 1, 2. So this is like, I don't know, whatever that is, 1.2, whatever that is, something like that. Here's what I want you guys to take note of. This part down here has a negative derivative, right? Between 0 and 1.2 or whatever that is, that means you have a negative derivative, okay? And then between 1.2 or whatever that is and 4, your graph has a positive derivative. Do you agree with that? Okay? And then after that, it has a little area over here that's negative, something like that. And so they want to try to have us assess f of 0, I'm just going to write these down, f of 2, f of 4, and f of 6. I'm not saying that this is bigger than this, is bigger than this, is this, and all that kind of stuff. But I want you to see, if you you can tell me a little bit about size-wise, which one is gonna be the biggest. Can you tell me which one is the biggest by looking at this? This means your graph is gonna head down, it's gonna head up for a really long time. Do you see how much area is underneath this? See how much area is up there? If this area is bigger than this area, that means f of 4 is gonna be the biggest, and then it's gonna head down. But it heads down for just a little bit. See how that area down there is not really all that big? In fact, we could find those areas. I don't think we necessarily need to. But which of these is the biggest? So think in terms of something decreases for a little bit, rises for a long time, and then decreases for a little bit. So this is a little bit of a min, this is definitely a max, and this is also a relative min at 6. Do you agree with me there? Yep. Now we could have done this a little bit by, I can. I can figure out what f of 0 is by just saying f of 0 would be integrating from 0 to 0. If I wanted to find what f of 2 was, or in this case f of 2, which they've actually asked me about, if I wanted to find f of 2, I would have to integrate underneath this function. Actually, I probably should just call this the derivative from 0 to 2, because our answer would be f of x, and then it would be 2 to 0, and then it would be f of 2 minus f of 0. So if I wanted to find f of 2, I would have to find this area, and then the area between here and here, and add them together. Would you get a positive or a negative answer? Look at your picture. If you added the area between 0 to 2 on your graph, look at it, look at the heights, look at the y values. My picture's kind of lousy. Think about it, think about it, think about it. This one goes up to 3. 1, 2, 3. And this starts down here at -4, right? And here's your graph. And if you guys are going to find this area and this area, is that going to be a positive or a negative? Look at which area is bigger. This goes down to -4, and it goes over to about 1.2. This width is less than 1. Look at your pictures. And it only goes up to 3. Which triangle has the bigger area? This one over here. You following me there? So f of 2 is going to be the area between 2 and 0. Adding these two together, it's going to be a negative number. Are you with me there? So let me just put this. This is going to be a negative number. Now, f of 0 is going to be 0. Because f of 0 means technically you're doing this. You're going from 0 to 0. Yeah?
I'm confused why we're doing area.
Because area, okay, again,
I thought that was capital F.
it is, but they just, okay, 2 ways we can do this. A lot of times when you see a graph like this, they'll just use little f of x, and then they'll do this. They'll put little f of x, which is known to be the derivative. The relationship between this and the thing that you end up with, this is your actual function. They just didn't use the actual notation of f of x. What they did is they said, this is the derivative, so what that means if I do this, and then if I were able to do the calculus, I wouldn't call it f of x, I would just call it little f of x. We normally use capital F, and they could have used capital F for each one of these, but they just said this is the derivative. This is normally a derivative. When we write this, that's the derivative. That's the relationship between these two. Normally we call that capital F. I'm just going and using the real letters. Like this is the derivative, and that means that's your original function. You know what I'm saying? It's still the same relationship, we're just not using the capital F. Okay, so 0, f of 0 is 0, f of 2 is negative. What are you feeling about f of 4? Looking at your area, adding the area f of 4. Now, look at all of that area. You tell me, positive or negative? Positive, absolutely. This is positive. Now, 6, f of 6, means that you also have to add on that little area down there. Do you think this little area is going to take away from the area that you have from f of 4 and make it negative? Or is it just going to decrease it a little bit? It's just going to decrease it a little bit. So this is positive also, but just a little smaller. Do you guys see what I'm saying? Because from 4 to 6, it took away a little bit of that area. Because if we added everything we've got so far, to 4 is the biggest, because you've got the most positive area added with this little negative. And we could find the areas if you wanted to add the trapezoids and the triangles and all this stuff. Do you want to do that? No? Okay. So what I want you to go with is, which one is the smallest of these numbers? Which is the smallest? f of 2 is the smallest because it's negative. So f of 2 would be the one on the left. We said f of 0 is 0, so it's the only other one that's not a positive number. And then we said f of 6 has to be the next biggest, and f of 4 has to be absolutely the largest because it didn't have any negatives past 4 to take away from its area. So it's, you okay there?
Yeah.
It's
I
definitely
was
a
looking.
different, I'm sure it's nice and clean now, because it was on the floor of school. I have to say, I did a little experiment after school yesterday. I was in the restroom, there was this graham cracker on the floor, and I was like, I'm just gonna sneak it. No, I didn't eat it. I snuck it like up to like the corner where like you'd really have to sweep it out if you really swept it out, just to see today if it's still there, to see if it really got swept out. Do you know what I mean? Like I just kind of did that.
Was it there?
I haven't looked yet, haven't been to that scene. I'll tell you.
That would scare me.
I'll text you guys about the graham cracker.
Okay.
Okay? If you get a text about the graham cracker and I say it's still there, just know that. That's it. The graham cracker's still there. No, it's not a graham cracker. It's an animal cracker. I couldn't tell what animal it was because I wasn't picking it up with my foot or my hand. I don't know what it was. Ah. Okay, any female have to go to the restroom? Go in the first stall and see if you like turn around, look at the stall, if there's an animal cracker on there, on the floor on the right-hand side. Have you ever been in behind the stalls? Okay, I know females, you're gonna find this before males, I've said this before to other classes, but if you've ever looked at the little, looked at the silver little locking mechanism, the word on there, the company's name, Honeymothers. I think that's hilarious. I saw that one day and I about busted out laughing in the bathroom. I was just like, oh.
Somebody's like, what are you laughing
I
at?
know, exactly. That's one of those times like in the library where you don't want to bust out laughing. Probably not, but tiny hiders. I just think that's hilarious. Okay, what else? Anything? 8. I'm sorry, you guys might have said 8 and I've been a slacker. Okay. Let's take a look at 8. All right, on 8, did they give us a function? Not quite. 8, they gave us f of x is g of x plus 7. What does a graph do when you have plus 7 at the end of it? Shifts it up 7. Everyone agree with that? So let me just do this for a second. If you guys were finding the area below y equals x squared from, I don't know, in this case, in number 8, it was from 3 to 5. I'm just going to kind of talk about this for a minute. If you were trying to find the area from 3 to 5, it's sort of trapezoidal but curvy, right? Now, if I said y equals x to the second plus 7, well then that would have meant you would have started your parabola down here, and it would have meant your x-axis could have been kind of like up here at 7. You would still have this same area, but then underneath it, do you see how you'd have a rectangle below here? And you guys could find the area there, and you could do it that way. Are you with me? Just want to kind of talk about that before we get into this. Okay, so here's 8. This is 8, you guys said. So this is for when x is in between 3 and 5. And they ask you to do the integral from 3 to 5 of f of x plus g of x. And, dx. So we're going to do a little substitution. First of all, f of x was g of x plus 7. So you guys are seeing me substitute without the orange marker here. Is that okay so far? A little substitution, it's a little bit like the one you guys had me do on number 6, but maybe not as bad. Okay, so here's what I end up with. I get 2 g of x's that are going from 3 to 5, and I can add those separately. And then I have one integral that just has 7 in it from 3 to 5. Now, we can either do this using the method that was given above, or actually they don't want to